Hi there. Today I'm going to go over these practice problems from chapter 18. I have posted this solution on titanium as well, so you can refer to that when you're preparing for the problems from this chapter. The questions in this chapter are about computing all those different performance evaluation metrics like Sharp, Trainer, M2, Jensen's, and information ratio. All right. Okay, so let's go over this first problem here. So you're given the information about a fund A, its average return over some past horizon. It's a standard deviation and beta. So some metrics use a standard deviation as risk, others use beta as a risk measure. S&P 500 is the benchmark for this fund, and you have that same information for the S&P 500 index as well. Okay, the risk-free rate of return is 6% over that same time horizon over which you are observing this risk and return numbers. Okay, so for this first problem we have to compute the four metrics: Sharp, Trainer, M2, and Jensen. So Sharp measure is the average return minus the risk-free rate divided by sigma, or standard deviation, right? Excess return divided by sigma. So fund has average return of 12.4%, 6% is the risk-free rate, so the difference would be in the numerator, 12.4 minus 6, and then the denominator would be sigma, so that's 30%. So 12.4 over 6 divided by 30, and that gives you the Sharp measure, 0.2133. Trainer measure is similar. You have the same numerator, average return minus the risk-free rate, and in the denominator, instead of sigma, you have beta. So 12.4 minus 6 over 1.3, so that is 4.9231. So that's Sharp and Trainer. And again, how you use this, even though this question is not asking us to do that, the question is only asking us to compute the measures for the fund. But whether the Sharp measure and Trainer measures, whether they are good or bad for this fund, one way to assess that is to compare that with the benchmark. So you can do the same calculation for S&P 500, right? So take the return for S&P 500 minus the risk-free rate divided by standard deviation, and check whether that is more than 0.21 or less than 0.21, right? So if fund has a higher Sharp measure than the benchmark, it outperforms. Same thing with the Trainer measure. Okay. Now next one is the M2 or M square measure. So here the goal, if you recall from our lecture, the goal is to match the standard deviation of the fund with that of the benchmark by adding in the risk-free asset or treasury bills to the fund, right? So we combine the fund with treasury bills to get a new portfolio that has the same risk or sigma as that of the benchmark. So our fund has a standard deviation of 30%, S&P 500 standard deviation is 15%. So we want to add enough treasury bills to this fund to bring down the risk from 30% to 15%, right? So this is the risk equation for our risky plus risk-free asset. Our target for the combined portfolio is 15%. That is the same as that of the benchmark. And we want to find how much to invest in the fund and how much to put in the risk-free, right? So this equation would allow us to compute Y. So 15% equals Y times 30%. 30% is the risk of the fund. So that would give us a Y of 0.5, and then 1 minus Y would be 0.5, right? So put 50% in the fund and 50% in treasury bills, and that would give us a new portfolio with a standard deviation of 15%, right? So here actually it is quite intuitive. We are trying to cut the risk in half. So if I put half in the risky fund and half in risk-free asset, that would give me a combination that would have a risk that is half that of the fund, right? So 50-50. So those are our weights, right? And once we have the weights, we can use our return equation to determine the the return of this combined portfolio, right? So proportion in the fund times its return plus proportion in the risk-free asset times the risk-free rate of return. 0.5 times 12.4% plus 0.5 times 6%, that is the risk-free rate of return. That would be the return on this combination, this 50-50 combination, and we get 9.2%, right? So this new portfolio has a 9.2% return and 15% standard deviation. The risk is the same as that of the benchmark, so we can simply compute or compare the return to that of the benchmark. So 9.2% versus 12%. So clearly the fund underperformed, and the difference 9.2 minus 12, negative 2.8%. That is the magnitude of underperformance, right? So let's say that the fund underperformed the benchmark by 2.8% based on M2 measure. Okay. And then the last one here is Jensen's alpha or Jensen's measure. So this is based on CAPM. You compute the return based on CAPM and compare that to the actual return, right? So that is what you see over here. So in the parenthesis here is the CAPM calculation, right? So risk-free rate plus beta times market return minus risk-free rate of return. So that's the return from CAPM. That is how much the fund should have earned based on CAPM. Okay, so if you do this calculation, you will get 13.8%. The actual return of the fund is 12.4. So 12.4 minus 13.8, that gives you negative 1.4. So fund actually has a negative alpha, therefore the fund underperformed based on Jensen's alpha. All right, so that's how you compute all these different metrics for fund A. All right, moving on to the second problem. So here we are given information about two funds and we have to compare their performance using information ratio. Fund A has average return of 13%, B has average return of 8%. The benchmark has average return of negative 1.5. So benchmark actually has a negative return, the same benchmark for A and B. Standard deviation of fund A's excess return over the benchmark is 8%. For fund B's excess return over the benchmark is 4.5, right? So which fund has superior performance based on information ratio? So information ratio is excess return over the benchmark divided by standard deviation of the excess return, right? So for fund A, return in excess of the benchmark, so that's 13% minus negative 1.5%. So that's your numerator, RP minus B, and the denominator is the sigma P minus B, the excess return over the benchmark, so that's 8%. So that would be 14.5 over 8%, you get 1.8125 for fund A. Similarly for fund B, it would be 8% minus the benchmark return, so 8 minus negative 1.5, so that would be 9.5%, and sigma P minus B is 4.5% here, so 9.5 over 4.5, 2.11. Okay, so which fund has a higher information ratio? Fund B has a higher information ratio. So based on this metric, we would conclude that fund B has superior performance. So even though fund B actually has a lower return, but its risk was much lower, and therefore on a risk adjusted basis using information ratio, we can conclude that fund B outperformed fund A.